going to talk to you about how we can use AI in industry. So there are lots of ways that we see AI being used in industry, and I know that we hear a lot at the moment about generative AI, but actually the commonest uses of AI that we're seeing in industry today are still traditional machine learning and statistics. For example, if you work for an educational institution, if we might say we know 5 numbers about this student, can we predict the likelihood of them failing their exams? So that's kind of machine learning that we do with linear models, with averages, sometimes more sophisticated models. Then there's another kind of AI that we're seeing in companies and in industry today, which is deep learning. So an example of that would be applications like computer vision, where you might want to classify a fire hydrant as, or a street image of the fire hydrant, or as a manhole cover, or something else like that. Generative AI, so that's something that's been in the news a lot recently. That's all the natural language processing models which help us to do things like write blog posts, write marketing. That includes GPT, Copilot. And then there's levels on top of that. So there's RAG or RAG, which stands for Retrieval Augmented Generation, and prompt engineering, which are people writing code to not just send the user's query to GPT, but actually add a load of extra information like legal information or industry specific information, and send that to GPT, and then get a result which takes advantage of everything that GPT can do, as well as all the information you've got in your database. Then another kind of AI, which is perhaps overlooked sometimes, is traditional natural language processing. So that's what I work in most of the time. Examples of that would be you have a document and you want to find all the companies or the drug names, or the entity, the product names and product codes mentioned in the text. Or you want to find all the dates and times, or you want to relate them, or find, is there positive or negative sentiment about this or that company. So that's something that sometimes gets a bit overshadowed by all the hype around generative AI, but has a lot going for it still. So if you have a business problem and you're considering using AI, I would first ask the question, is AI even needed? So an example would be, you want to work out the cost of building, of doing a building project. So you might say, can we use a neural network for this? But I think that would be overkill. And actually, one of the simplest ways of modeling that is just take a reference class, so take all the similar building projects that have been done in the past that are comparable to this one, and just average them. And so, and also, kind of when I get taken on board a company and we're looking at AI initiatives and working out, is this or that initiative worth doing, then quite often we look at the effort that would be involved to do each potential thing. So let's say predicting the cost of a building project, or predicting the risk of it failing, or automating or triaging incoming customer queries, let's say. And each one we'd work out, is it high impact or low impact on the business, and is it easy or hard to do technically? And it's very nice to do this analysis. It's nice to do this analysis before you really get stuck into any of the machine learning projects, because you can work out if it's actually worthwhile doing what you're doing. So in my experience, some of the most common and the most beneficial initiatives that you can do in AI would be things like predicting the costs or the risk or the duration of a product, or of a project. So, for example, imagine you have data on 100 clinical trials that have been run in the past within your organization. For each clinical trial, you know a few things about them, and for the past clinical trials how much they cost. What you want to do is, for a future upcoming clinical trial where these data points, predict the cost. And that's something that's really, really valuable in all kinds of industries: predicting cost, or predicting risk of failure, predicting if a building project is going to fail and result in litigation, predicting if a ship entering into a harbor is likely to be impounded by the port authorities. These are all kind of things that are really quite powerful in terms of their impact on the bottom line or on the risk exposure of an organization. And actually, we spend a lot of time talking about generative AI when really we should be looking at this. So here's an example. So what you might have in the clinical trials example. So here's a public data set of clinical trial costs and risk of cost assessments. And so the final dollar value of running a clinical trial for a number of trials that were running in the past, together with the dates, the type of investigation, the disease that was being investigated, the number of participants, so a number of kind of quantitative values that we have around the trials, and then the final cost. So this is the kind of thing where if you wanted to predict the cost of a new trial, then you would look at similar trials. So you have a leukemia trial coming up. You say, let's look at all our leukemia trials that we've done in the past. And then say, look at the leukemia trials in this phase, or look at the leukemia trials with this number of participants. And then you might say, let's look at leukemia trials which involve biological drugs instead of small molecule drugs. So, and then you take the average of those and you look at the distribution. That's really, it's not sophisticated machine learning, it's not rocket science, but it's really, really powerful, really, really impactful. And I recommend always looking into, the potential for this kind of initiative when you're doing an AI project, or if you've just been onboarded as a data scientist in a company, or you're undertaking some kind of AI transformation in an organization, looking for things like this. This is where the impact is going to be. So predicting cost, risk, and duration with regression models, or even with just simple averaging, this is really simple to understand in terms of maths. Quite often, the obstacle is actually getting hold of the data. You might have to go hunt down data, talk to people. In the clinical trial domain, for example, that data is not public. It's not public domain. And you have to clean it. You have to, combine it from different sources. So that's where the legwork is normally on that kind of project. So we've had a few examples of these in fast data science. So one of them is the NHS, National Health Service in the UK. They have data on the payroll of all the people working for the NHS. So the NHS in England employs 1.2 million people, and they wanted to predict the likelihood of one employee leaving the organization. And so you have information on other employees' qualifications and their tenure in the NHS. You can use this and then build a simple regression model. We've done a similar project for an arm of the Scottish government where they had data on young people and whether they stayed in education and employment or left education and employment. And we've had a project for Tesco, which is the largest retailer in the UK, and similarly identifying the value or the total weight in kilos that somebody's going to put in their shopping basket. That's something that, it's, again, you can mostly get most of the way with average, with averaging values of that customer or that region, and then you can add in a bit of regression, a bit of seasonal modeling, and you can get quite a nice prediction which really impacts the bottom line of the business. So I'm going to move on to the next part of machine learning that we're going to talk about, which is neural networks. So neural networks really took off from around 2015. This was thanks to a guy who called Thomas Mikolov, who did a PhD and developed a convolutional neural networks, which is a really kind of groundbreaking model, which can distinguish images of cats and dogs and all kinds of do really, really, clever things with incoming images, which before then only humans were able to do. So we can use this for tasks like, for example, classifying a retina as a particular, indicative of a particular disease or not, or classifying wind turbine blades. These are examples I've seen, or the street example, classifying manhole covers, fire hydrants. In the text domain, you might do things like you might use convolutional neural networks to match a CV to a job description, or predict the salary of a CV, or predict the industry of a job seeker based on the CV. Spotify is using this, and Last.fm, I think, have been using this for song recommendations based on the fingerprint of the actual audio file that they have, and based on listening habits. So this is something that is great for when you don't have, let's say, a little bit, small numbers of features like you do in this case of the clinical trial project, but actually you have, large things like video, audio, or text or image files, and you want to do some kind of regression or classification model with them. So this is one of the really cool things that I like that you can do with convolutional neural networks. So there's a challenge called the ImageNet Challenge. The ImageNet Challenge has about 1,000 categories of images, and convolutional neural networks are tested on their ability to distinguish all these different kinds of images. So these two, we've got a husky on the left and grey wolf on the right. And once all these groundbreaking convolutional neural networks came out, suddenly we had apps and computer programs that were able to distinguish, dog breeds from one another, which is just absolutely amazing considering where we were a few years before that. So there are a few pros and cons if you want to use this in business, in a business setting. So first of all, I'll repeat what I said, which is really, really helpful to first do your cost benefit analysis and work out where you'll actually get the benefit from doing an AI initiative. And actually the simpler regression models, I would look into doing some of those first, because this is a lot more involved to do any kind of machine learning or neural networks and deep learning and actually deploy it in production and get it running. They are expensive to train, they are expensive to develop, they need a very skilled data science and software engineering staff to actually do it. You often run up a very high cloud compute bill. So whether your provider is Amazon, Google, or Microsoft, you will have a bill. Normally, you can get 1 or 2 years of free cloud usage, but still the cost is going to go up. And secondly, the deep learning component alone is often not enough to actually get business value out of it. So imagine, here's a case of, an ultrasonographer. If you want to replace an ultrasonographer with a deep learning system, it's still not going to, allow you to replace human workers with machines, because, that's not all that a person does in their job. And there are very few jobs where the only task that a person does is just look at an image and classify it as, A or B, or as, husky or wolf. And so sometimes I'm not sure. Sometimes I think these projects get done. This kind of project, the deep neural network project, or developing and deploying a convolutional neural network for something really, really cool that, technically is really exciting, but actually sometimes it can be a bit hard to see the value. So the next one is natural language processing. So natural language processing, like I said, this is the area that we work in fast data science. It's what I've been doing for over a decade. So natural language processing is typically the use case is a company may have been accumulating over 10 years, 20 years, huge amounts of unstructured text data. So that often happens in certain industries, such as legal industry, financial industry, medical, pharmaceuticals, or insurance. An example would be in shipping, when a ship is inspected by port authorities under international treaties and called the MOU, their inspection report is written up as a PDF in Word. And then what we also have is data on where ships later detained. So if a ship is detained by authorities, that means it's held for 5 days or so in one location. It's not allowed to leave. Shipments are delayed, and the company operating that ship then loses a huge amount of money. So imagine, if you could have a smart graduate who was able to read all your documents that come in, and they also have a feel for your business, what the business processes are. If they read one of these ship inspection reports and saw, oh wait, okay, it mentions that there's insufficient lifeboats, but we're just about getting away with it this time, then they would flag that. And you would remedy it. So NLP would be something, when NLP is done properly, you can actually identify these patterns automatically, which is great. And then you could end up with some kind of machine learning model where you input the PDF of a ship inspection, and you get out a risk assessment, which is very, very powerful. So we're working on quite a few examples in the clinical trial space where you have the protocol, which is a 200-page document around the clinical trial, which describes all the details of how it's going to be run, the number of participants, the number of sites, and the intervention. So, what kind of drug is being given, how often it's being given, whether the participants have to come in and stay overnight, how many times they have to come into a clinic or a hospital, and also how the statistical analysis will take place. So we're working on models at the moment where you can drag and drop these PDFs, and you'll get a prediction for the dollar value of that trial just from the raw PDF. So if I go back to my earlier example, here I had a table of structured data. So I had tabular data on past clinical trials, but in reality, we often have a PDF. And then that is that can be quite hard to process. So you need a lot of smart machine learning and we can do a mixture of traditional machine learning and state-of-the-art NLP. The NLP will get features out of the PDF. So I can have a machine learning model where I drag and drop a PDF into it. It will find the number of subjects. It will find the number of sites. It will find the intervention, the drug, is it biological, is it small molecule, and how many sites are we running in, what country is it running in, and so on. We can find all those bits of information and then feed them into a separate cost model, which is, again, using the simpler kind of machine learning, and you get advantages of both the state-of-the-art NLP and the simpler machine learning. You can also even combine generative AI into this. So really, this is a hybrid approach where you get all kinds of advantages, or the advantage of both worlds. So generative AI, just a word around that. So there's often quite a lot of misunderstandings around what generative AI can and can't do. So if you remember old mobile phones and the predictive text that they would do. So GPT and Gemini are basically the next generation evolution of what the old Nokia phones were doing. So given a sequence of words, what's the next likely sequence of words? It often gets misunderstood or misused as if it were a search engine or some form of information retrieval system. That's not the case. But they are very powerful. They're very good at doing reasoning. They're very good at kind of producing plausible and convincing sentences. So you can also implement these into your pipelines, whether that's hybrid AI or any other kind of system, or just a pure generative AI system. However, a lot of people using the generative AI solutions and using third-party providers. So that would be Google, Microsoft, OpenAI, and so on. Word of caution around that would be if you are using a third-party provider, make sure not to send anything that you don't have permission to send, or so if you have company internal data, personally identifiable data that would put you on the wrong side of the GDPR. If you were to post it on social media, the same applies to sending it to OpenAI. So just be careful what you're sending, that you actually have permission to send that. They have amazing capabilities. As we've seen, they are prone to hallucinations. So they can make up, I've seen them make up statutes, make up laws that don't exist in England or any other country in the world. They can be slow. If you implement a solution which relies on a generative AI provider, then you are dependent on a third-party provider continuing to provide the service that they have been providing, continuing to provide it reliably at a reasonable cost. So we need to be aware that any business proposition that is built as a wrapper around GPT is not likely to last very long. You also have the option of training your own LLMs, and that's orders of magnitude more expensive and more involved and more difficult than training your own convolutional neural network or image classifier. So I haven't done this, but it looks very difficult. If you are working with generative AI, there is a really cool solution you have to some of the issues around hallucination. So there is prompt engineering, and there's RAG, or retrieval augmented generation. So in this case, the scenario is a company has a database on very, very domain-specific information. So imagine you want to make a question-answer bot around insolvency law, English and Welsh insolvency law. We can, instead of just sending a user's query to GPT and then getting a response that involves all kinds of different jurisdictions and non-professional advice, you can actually send the relevant snippets of insolvency law, and then append to the end of that message, you append the user's original query. So you can say Insolvency Act 1986 section 216 says if you close a company and reopen another company trading on the same premises or with the same name within a certain number of years, then that could make you liable for any debts of the previous company. So that's something that you might tell GPT, and then you send GPT the user's query, and you get a response taking into account what the Insolvency Act says. This way you can eliminate the problem of hallucinations or reduce the problem of hallucinations. You have to be careful, again, if you are sending, for example, snippets of law to GPT, that's stuff you have permission to send, that it's in the public domain. You can't go and take bits of text that are proprietary in any way. And again, don't send anything to GPT that you would not post online. So to summarize, we've got traditional machine learning on the left. This is, things like graphs, regression models, and so on. They're simple, quick, very cheap to deploy, very easy to predict numbers. They're not particularly powerful. They're not, particularly intelligent. And they need very structured input, which means a lot of legwork to assemble the input that they need. Then we've got deep learning. That's, things like the convolutional neural networks that are able to classify images of dogs, cats, huskies, and so on. So that gives us very impressive, very high accuracy, human-like classification of image, text, audio, or video. These need a huge amount of data to train. They take a long time to train. They're very expensive to train. They're expensive to operate, but they're quite powerful. They don't really solve a business problem on their own. And I think traditional machine learning is the main one that is easiest to get a business result from. Generative AI. So again, this is things like GPT. You can get human-like text responses. However, there's a lot of legal gray areas around that, around what you can and can't do with generative AI. You shouldn't be sending private, personal, sensitive, or proprietary data that you don't have permission to send to GPT. It can be slow. If you do implement these solutions and you are using a third-party provider, you're then dependent on that third-party provider. Hallucinations are an issue. There have been a number of lawsuits, such as Getty Images and Stability AI, where Stability AI had been using some images from Getty Images library. So there are all kinds of lawsuits between traditional content providers and the tech companies that are offering generative AI solutions. Then finally, there's natural language processing. So if I, were to treat that as a separate area from generative AI, obviously there's overlap between all these areas. Natural language processing involves any analysis of text data. So that's often PDFs. Very often, companies have huge amounts of PDFs of clinical research data, of insurance claims, of house inspections, of ship inspections, and so on. It's very hard to do, very hard to get. Natural language has all kinds of patterns that is very hard to model with, but this also gives you high value if you can get some useful and meaningful predictions using a natural language processing model, especially if you can build some kind of hybrid AI combining natural language processing and traditional machine learning. So I'm just going to walk through a couple of examples of what we have been doing in fast data science. So the first one is the clinical trial risk tool, which is a tool that we have been developing using natural language processing, and it allows a user in the clinical trial space, so that could be a research organization or a clinical trial funder, to drag and drop the protocol of their clinical trial, which is a 20-page PDF plan of how they're going to run the trial. And the tool identifies key features such as the sample size, the presence or absence of a statistical analysis plan, and then calculates a risk of the trial failing, and we're working on cost modeling. So this is, an example of a very high impact kind of natural language processing models that you can do when you combine natural language processing with machine learning. With traditional, very simple machine learning, you've got a kind of hybrid AI model. We're using some neural networks in this. We are not using generative AI for a number of reasons, mainly what I mentioned in the last slide. We have our project, which is the Insolvency Bot, which is a generative AI project using GPT and retrieval augmented generation, or RAG. So in this one, a user can ask the Insolvency Bot questions. It is not legal advice, but they can ask questions about English and Welsh insolvency law, and we augment their query with insolvency statute and case law and information around HMRC's procedures. We send that off to GPT or any other LLM, and we get a response, and we return it to the user. And this has been a really interesting experiment, showing how RAG can actually help to mitigate the problem of hallucinations and help to really bring out the power of generative AI by augmenting its capabilities with a bit of information retrieval from a separate system. For the World Health Organization, we've been building a system, or rather a dashboard, which allows anybody around the world to explore the results of a survey in natural language, in the native language of the respondents. So this one we use generative models to classify, and so not off the shelf GPT, but we trained our own classifiers using the Python library Hugging Face, and we have managed to classify, millions of survey responses, and we've displayed that in a dashboard for users to explore. Thanks very much. If you have any queries, please contact me at fastdatascience.com.